Hi everyone, thank you for joining us today for this new webinar session on crypto agility. So there is a lot to say on crypto agility. So today we wanted to at least put the topic into add the context into the topic crypto agility, what it is all about, why we should implement crypto agility. And it's going to be a subject we'll dig further in the coming months this year. So this webinar is being recorded, so we'll send the video in the coming days. And feel free to ask any questions on the question module. We'll try to answer it at the end of the session. So it's we have a lot to say today, so hopefully we'll have time for a couple of questions. And if not, for sure, we'll come back to you later on. So let's begin. Today, to discuss the subject, you will have two people. I am Nicolas Dro, in charge of the marketing and communication for cryptographic security. And Julien is with me today.
Yes, thank you. Hello, everyone. Yes, I'm Julien Pratt, cryptography engineer at cryptographic security.
So a few words about cryptographic security. So we have an academic background. So our founder was a researcher in post-quantum cryptography. We've been working actively, contributing to the collaborative works of the NIST, of the IETF, and so on. So we offer solutions to help companies doing their transition to post-quantum cryptography with the three main phases. So we have solutions for the preparation phase to help them inventory their cryptography. We have a quantum safe library to help organizations protect against quantum computers. So a library gathering all the validated and other quantum safe algorithms. And we have solutions to help companies managing their crypto agility, and it's the subject we are going to discuss today. So as an introduction, what is crypto agility? So we like to start with this slide. So some of you may have seen it already, because cryptography is the main pillar that support the whole security of your company. So all your cybersecurity solutions, such as PKI, HSM, IAM, Zero Trust, and so on, are relying on this, on cryptography, and the business operations are supported by these. But what happens if cryptography breaks? Then it's the whole building that is collapsing, because the digital signature doesn't mean anything. You can be sure that you have been validating contracts, whether internal or external contracts. Anyone can read your confidential data. You can't be sure that the servers or the employees connecting to your private networks are legitimate or not. So it's the reputation that is that could be tarnished, and the cost could be huge to remediate to this. Even it could be the survival of the company that could be in danger. So the solution is to replace the traditional asymmetric cryptography, such as RSA or elliptic curves based on cryptography, by PQC, post-quantum cryptography. And it's going to be a long journey, a long project to do so. It could last up to 10 years for a minimum of 10 years for large companies. And it requires a lot of time. It requires skills, dedicated skills, specific skills, and of course, it's costly. But you don't have the choice, and companies need to do this move because they could be vulnerable to quantum computers attacks in the future. But once you've done this, if the algorithm, the quantum safe algorithm you've been deploying would be found vulnerable, or if the regulation would change, would you start all over again? Of course, it's going to be a painful, another painful project. So that's the main idea of crypto agility, is to help you not doing that again. So the common definitions, the definitions of crypto agility are more or less the same, whether the institutions or standardization bodies. It refers to the ability to add, modify, or deprecate the use of a cryptographic asset without disrupting the operations of the company. So it means accelerating the responses to cryptographic vulnerabilities, or lowering the costs if you need to remediate to this, and taking back control of your cryptography and improve the resilience of your company. That's the main goal of crypto agility. And it goes by cryptographic assets. We mean it's much more than cryptographic algorithms. It's about algorithm, keys, certificates, protocols, libraries, and configurations, and so on and so forth. So it's that requires skills and tools to be able to do so. And to finish with this introduction, we found out that there was a convergence of statements regarding crypto agility from institutions, national security agencies, or analysts. They all agree on the fact that crypto agility has to be implemented to facilitate the PQC transition, of course, but to protect against future threats, to reinforce resilience, and especially it's a no-regret move in a sense that whatever PQC or other type of cryptography you have to implement, crypto agility will help you to improve the resilience of your company. So it's a no-regret move. So why do we need to deploy crypto agility now? I'm gonna turn to Julien about this.
Thank you, Nicolas. So yes, let's answer now the question why we should consider crypto agility now. So Nicolas already told you about the quantum threat, which is our main concern here at Cryptonic Security. But there are much more reasons why we will need to implement crypto agility and to switch from an algorithm to another. So one of the first reasons is that the cryptographic standards continuously evolve. As you may have heard of, NIST has standardized for the last 2 years 3 new standards, FIPS 200, 03, 04, and 05. Which specify 3 new algorithms, MLDSA, MLChem, and SLHDSA. So 2 of them are signature algorithm. The last one is a key encapsulation mechanism. So they have been standardized by the NIST, meaning that they are standards and they will have to be implemented at some point. Regardless, the quantum computer becomes a reality. So basically, standards evolve, and it concerns not only asymmetric cryptography but also symmetric cryptography. For instance, NIST is considering standardizing a new encryption mode for symmetric cryptography. As you may know, that GCM mode has some weaknesses in some specific use cases. So NIST is considering replacing GCM mode with a new one, and to provide a new standard dealing with this encryption mode. So basically, standards evolve continuously. The second reason why we would have to implement crypto agility is because we have to adapt cryptography to national agencies' recommendations. So the algorithms to be used and implemented are different depending on the geographic area where you want to operate. So algorithms will be different in Europe, in North America, in Asia. So each national agency has its own recommendation. So we have to be able to switch easily from an algorithm to another, or to a parameter set to another. So basically, that's the second reason. Third reason is that new attack vectors emerge, well, not every day, but every month. So we've talked about the quantum threat, but actually cryptanalysis is an ongoing process, and there are new vulnerabilities that can occur on existing algorithm. And another research topic is the side channel attack. So there are many attacks that are being published every day on all the algorithms. So we have to be agile and to be able to replace an algorithm once a major vulnerability appears. So that really concerns the algorithms by itself, by themselves. And there is a last reason for being able to replace an algorithm. The last reason is that implementation flaws are regularly discovered. So even if the algorithm is really robust, there can be some weaknesses in the implementations. So we have to be able to easily switch from one implementation to another. So that's another reason to implement crypto agility. And as a conclusion to this slide, actually, crypto agility is essential for protecting against future threats in general, and should not be restricted to post-quantum algorithms. So post-quantum migration is a must because it's recommended by national agencies, but actually, and it will be a bit painful. So we have to take this and as an opportunity to commit in good processes and good developments, processes to make sure that we will do this transition only once for this migration, and then the next migrations will be very smooth. And even if a new algorithm appear, it means that it will be smooth in the next migrations. Basically, that's the idea. So yes, this slide to illustrate what I just said about the vulnerabilities that can be found in the algorithm implementations. So here is a table giving the number of vulnerabilities that have been discovered on several open source cryptographic libraries. Well, and basically, these libraries are used in maybe 95% of the implementations, the cryptographic implementations worldwide. So we can see that, for instance, for OpenSSL, we found 203 vulnerabilities between 2005 and 2022. So it's a lot. It means that a library, even if it's used a lot, it's still we can still find some vulnerabilities on this library, and a cryptographic library and a cryptographic implementation has a long period during which the implementation is not so robust, and it takes a long time for a cryptographic library to be mature. So basically, that's why we have to really be able to switch from an implementation to another, and it has to be very easy to do so. So let's have a simple example on how an algorithm replacement happens, actually. So let's have a look on this diagram. So if we want to change from an algorithm to another, so at the beginning, we have two entities. We have the cryptography officer on the left and the end user application on the right. And the current situation is that the end user application supports, for the moment, algorithm 1 and is provisioned with keys for algorithm 1. Because yes, for an algorithm a cryptographic algorithm to run, we need two things. We need an implementation of this algorithm, and we need keys for this algorithm. So at some point, the cryptography officer will request to upgrade the algorithm, the application to support algorithm 2. So this is this stage. Application will support at some point after a migration algorithm 2 and will be provisioned with keys for algorithm 2. So here we will define several levels of agility. So the first one will be the software agility. So it consists in being able to switch from an implementation to another. So here we will update the cryptographic library to be able to support the new algorithm. And the second agility level is the key agility. And it means that we will be able to dynamically distribute keys for a new algorithm. So it's the key agility. So here at this point, we have used software agility and key agility, and now the application supports algorithm 2 and is provisioned with keys for algorithm 2. At some point, once the application has been upgraded, the crypto officer will request the application to use this algorithm, this new algorithm, algorithm 2. And at this level, there will be a period during which the application will be able to use the new algorithm, algorithm 2, but will also have to keep on using algorithm 1, especially to communicate with applications that have not been upgraded. So it's a transition period during which the application will use both algorithms. So at this point, we introduce a new agility level, which is configuration agility. So configuration means that the crypto officer requests to use a new algorithm. So here it's really a configuration matter to specify application. Okay, now you should use this algorithm. So it's configuration agility. And so there is a period during which the application will use both algorithms. And at some point, once all the applications within an infrastructure have been upgraded to support algorithm 2, then crypto officer will request to forbid algorithm 1. And at this stage, then the application will use only algorithm 2, and the algorithm 1 will be considered obsolete and will no more be used. So, and at this level, it's again a matter of configuration agility. You will only tell the application, okay, now you support only this algorithm, this new algorithm. So basically, that's the full view of algorithm transition scenario. So we can see that it's not a trivial operation. There is several agility levels to be considered. And there will be several steps to consider to migrate from one algorithm to another. So now, if we had the diagram. Now it's more a verbose slide here, but summarizing what I just said. So we have three levels of agility: the software agility, which will consist in being able to upgrade the cryptographic library used in an application, either to add a new algorithm or to update an existing algorithm implementation, especially if a flaw has been discovered, or if you have a new implementation, which is, for instance, protected against side channel attacks, or which is more optimized in terms of memory or in terms of performance, runtime performances. So basically, you can switch from an implementation to another. The second level is the key agility, where you will be able to provision your application with new key material, supporting the new algorithms. And the third level is the configuration agility, where you will be able to give a configuration to an application, a cryptographic configuration, and this, well, in the rest of the presentation, we will call this cryptographic configuration a crypto policy. And so what a crypto policy is really, it's a set of rules, of cryptographic rules that should be applied to an application. So a cryptographic rule will be, for instance, just the algorithm to be used. It will be the library that will be used to run the cryptography. It can be the keys to be used. It can be the key size to be used. So a lot of cryptographic parameters that will be applied to an application. So that's what a crypto policy is, a set of rules to be applied to one application or to a whole infrastructure. So let's go further into details and describe you how to implement crypto agility. Oops. So crypto agility actually relies on 5 pillars. So the first one, the first step before migrating a system to a crypto agile system, the first step will be to perform a cryptographic inventory. So this stage here, the first stage, consists in well, scanning all your infrastructure and listing all the cryptographic assets you have in your system. So cryptographic asset can be implemented, well, library, keys, certificates, well, everything related to cryptography. So that's the first stage, being able to assess all the cryptographic assets. Then you will have to migrate your applications to support Crypto Agile API. So what a Crypto Agile API is, it's basically an API which will remain exactly the same even if we change an algorithm. I will come back to it later. Then the first stage will be an automated key management to allow you to distribute dynamically new keys, new certificates for a new algorithm. Then there is the fourth stage, which is the crypto asset management. So it's a generalization of the key management. In this stage, you will be able to distribute not only keys, but also new cryptographic libraries, new configurations to your applications. And the last stage is the continuous monitoring, in which you will just analyze your infrastructure, the logs coming from your applications, to make sure that the cryptography that has been defined here as a crypto policy which has been defined is really the one which is run in your application. And then it's really a circle, a virtuous circle, because you won't be able to migrate all your infrastructure at once. So you will have to do it progressively, and to do first to migrate first a part of your infrastructure, and then keep on doing the cryptographic inventory, migration, crypto agility migration, and so on, to in the end migrate all your infrastructure. So it's really a step-by-step process and a continuous process. So let's have a short focus on the crypto agile APIs. So to define what it means. So basically, for the, well, currently all the cryptography is, well, in most of the time it's hard-coded. So it means that well, the cryptography is really tied to the source code. So which is a problem, because if you have to, well, let's say you have a lot of applications in your infrastructure. So you will have several things to migrate. So first, if you have several programming languages, you will have several cryptographic libraries to migrate at the same time. If you have an algorithm, even if it's, well, a library provides several algorithms, there will be one way to call one algorithm. So the source code will be different depending on the algorithm you call. If you want to run RSA signature or ECDSA signature, you will have two pieces of code, two different pieces of code. And there is another dimension. One developer equals to one way to call an algorithm. So even if you have you use RSA or MLDSA, depending on the developer, the way to call the algorithm will be different. So you will have to migrate it equally. So that's another issue. So it means that depending on your source code, the algorithm change will imply a lot of efforts and a massive software updates, mean that you will have to perform again the validation, certification in all your infrastructure for all the modules in your infrastructure. So it will be very painful. And so the solution is to use a cryptogel API, which is an API which is totally agnostic from the algorithm. So it will be only the same source code, regardless the algorithm is called behind. So basically, the idea is to have exactly the same code, even if you use RSA or MLDSA. So basically, that's what a cryptogel API. And to have a cryptogel solution, you need to implement this kind of API. And the second focus on the crypto asset management. So here is an example of an infrastructure where you have several business applications on the top. And as an example, a TLS proxy here, a VPN server. And within this infrastructure, you will have different configurations. Here on the first application, you have one software, one algorithm, one key, different key and different library for this second application, different algorithm for this TLS proxy. So quite complex architecture, cryptographic architecture. And in the end, at least the security level of the infrastructure will be equal to the weakest link within the system. So even if you migrate your application to here, if the TLS proxy has not been upgraded, it means that your security level is at the level of your weakest link, so at the level of the TLS proxy. So the solution here, to be able to unify the security level and to master the security level of your system, the solution will be to have a centralized crypto asset management done by the crypto officer, who will be able to distribute remotely and to manage remotely all the cryptographic assets within the infrastructure. So basically, that's really the crypto asset management, centralized crypto asset management. And it's really an important pillar in a crypto agile solution. So as a kind of conclusion, we try to define some maturity models, crypto agility maturity models. So we define the level 0, where all the algorithms are coded. The level 1, defining specifying a module where the cryptography can be locally configured. The level 2, where you start using crypto policy, defining a set of cryptographic rules, and the highest level 3, where you implement an inventory and a centralized crypto asset management. And this level is really the level where you have a real agile infrastructure. And currently, it's most organizations operate at level 0 or level 1 in the best case. So it means that yes, there is some work to do to switch from non-agile infrastructure to a full agile infrastructure. And it's some work, but it can be done step by step, and it's doable. Don't worry. So yes, maybe that's it for the presentation.
So I think we are reaching the end of this webinar. Thank you, Julien, for this very interesting presentation. I'm going to look at the questions to see if you asked. So we are running out of time, so maybe we can take 1 or 2 questions. just before, for those who can stay like a couple of minutes with us. Here is one. How do we justify the ROI of crypto agility? I think I can take this one, Julien.
Okay.
Actually, defining an ROI with a cybersecurity is always a bit tricky. The thing is that actually the Boston Consulting Group has been estimating the cost of the PQC transition to 2.5% of your annual IT budget. So it means that if it takes you 10 years to do the PQC transition, it's going to cost you, based on this assumption, it's going to cost you 2.5% of your IT budget for 10 years. And if you don't implement crypto agility, and if you have to do another transition to another algorithm because for any reason, so for example, if the regulation is changing, then you will have to pay again this 2.5% of your annual IT budget for the time it will take to set up this new transition. So it could be an indication of how much it's going to cost you. So the ROI could lie here, could lie there, means that if you don't set up, if you don't implement crypto agility, then it could cost you a lot in the future. Let me check if there is other questions. Are there any resources on how to adjust applications to being crypto agile? It can be quite complicated to adjust code to be configurable. Maybe it's one for you, Julien.
Yes. So, so I guess you mean, is there any, let's say, generic pattern to be able to replace the hard-coded calls to cryptography within an application? So I would say that there are some patterns that can be used to detect in your code where you call cryptography. And yes, indeed, there is no automatic process to replace, for the moment at least, there is no automatic process to replace an algorithm call within an application, but there are some means to detect at least where the algorithms are called, and then, well, at least detecting this pieces of code is the most tricky part. After all, implementing some code patterns within the code is not so hard. So basically, yes, there are some tools that can help you at least to detect the algorithm calls within an application. I'm not sure I answer your question, but.
And I think we are reaching the end of this webinar. Thank you, everyone, for listening to this webinar. I'll send you the recording in the coming days. And we'll wish you a very good afternoon. And feel free, if you have any questions, to contact us through this email or on the website directly. Thank you. Have a good day. Bye.
Thank you. Bye.